All right, so hello everyone. Welcome to code generation from an OpenAPI schema to PowerShell module in 4 easy steps. Glad you're here. We're excited to be here. My name is Daniele. I'm a software engineer at Pure Storage. Hopefully you guys have heard of us, have talked to the smart people outside in the booth, have seen some interesting demos. For those of you who have not heard of us before, putting very simple terms, we work with data storage solutions. Started with flash storage, but we have a growing portfolio. So make sure to check our booth and see all the cool things we're working with. And I'm here with my also coworker, Zhenhao.
Hello, everyone. My name is Zhenhao, and from Pure Storage. So both Daniele and I are software engineer, and we are from the integration team. So our team works on multiple PowerShell projects, and one of it is Pure Storage PowerShell SDK. Pure Storage PowerShell SDK, and this SDK serves for the Pure Storage flash array. And today we will bring you some secret sauce of how we cook the Pure Storage PowerShell SDK using the code generation. So less effort, and the code will write the code.
And here we have some contact info in case you guys have some questions later or want to sync on how we did the stuff. OK, sorry. So quickly through our agenda today, we're just going to briefly show our real case scenario, which is the PowerShell SDK 2 that Zhenhao mentioned. So what we achieved there. Briefly talk about the technologies we used, and then we introduce a simpler example, which is the pet store example. That will make it easier to look into the demos. And then we just go through the two approaches that we have tried, the one with Mustache and the one with Vision 2, so you guys can see which one is better for your case. All right, so first, simple introduction about the PowerShell SDK 2. So hopefully this will work better now. For those of you who have never seen a flash array, that's how the web UI look like. I have some interesting information about the array, the status, latency, bandwidth, a lot of cool stuff. And if you go here to the menu, you have a few options. If you go to storage, and you can see your volumes, create new volumes, assign them to hosts, take snapshots. You can see a list of snapshots here. So a lot of cool stuff that you can see. And then if you're trying to do like a one-time operation, maybe you just want to create a volume to try something, or you just want to see the status of your volumes, you can just do that through the web UI. But if you want to incorporate that into your workflow, maybe your daily backups and something like that, you probably want something that you can script on. So if you go here on your help, you have a few ways that you can interact with the flash array. You have your CLI, and you have a couple of REST API versions. So we mostly work with the REST API version 2 here. If you click on that link, you're basically going to come to this page where you have the help. And then you see like a bunch of different operations that you can do through the REST API. For example, you can go to the volumes here. And then you can list your volumes. You have all the examples of all the parameters that you have to use, the example of the response. So everything is there. And for some of our customers, that will be enough. And that's what they're going to use to integrate with their scripts. On the top here, you have the OpenAPI specification for the REST API. So you can download that. And you can take a look at how it looks like. So for example, if I look at my outline here, who has worked with OpenAPI specification before and knows how it looks like? Cool, 5 people. So yeah, so you have your tags, so all the endpoints there that you can interact with. If you close your tags, you can see your paths. So you have a description of your methods, the parameters you're going to use, the expected response. So basically, all the information about your REST API is there. So cool. So once you have that, as I mentioned, most of our customers, a lot of customers can be happy with just that. But some of our customers don't want to be worrying about how to do a REST call and how to handle all the standards and all that. So we try to provide some tools for them to be able to interact with the flash array easier. So we have some SDKs for different languages. And we create a PowerShell module to let PowerShell users interact with the flash array easier. So our PowerShell module looks more or less like this. Oops, let me do like that. Yeah, it's kind of frozen. Cool. Oh, there it is. It's the Pure Storage PowerShell SDK 2. That's actually a real module that we publish. You can download it from the PowerShell gallery. If you have a flash array, you can play with it. You should be playing with it if you have a flash array. And then if you get the commands, you see that there's a lot of commandlets. It's basically all the operations that you can do with the REST call. They are here. And then you can do a get help. For example, let's do update volume. And you can do a full. And that will give you like all the parameters that you have to pass. It has a description on top. So everything that the user needs to know to use this SDK. And so, yeah, basically that's what we did, and we're going to show you today how we did that. All right. So what was the goal? We have an open API specification schema that was provided by our Pure team that creates the REST APIs. And we want to have a PowerShell module at the end that has a REST client for the REST API. So we have to create a process in the middle that makes this come true. So first, we thought we could do a manual approach, of course. We know how to write PowerShell scripts. We know how to make REST calls. But as you saw, there's a lot of commandlets. We had over 150 paths on the Open API specification. And we kind of have kind of often releases. Just last year, we had 7 different releases for this REST API. So it could be done, but it would probably be very hard for our team to keep this up to date for all the different releases. If everything gets added, we might have forgotten a parameter or another. So it will be pretty hard to keep that up to date and working. So as you can guess from the title of the presentation, we decided to go with code generation. That will make the process faster and more reliable and all that. And so I'm going to briefly talk about the technology that we use, just so you have an idea when I'm mentioning them on the demos. Oops, sorry. First one, you already saw the file, the Open API specification. It's the file that basically describes all your REST operations. It's a language agnostic interface. It lets you specify parameters, the methods, requirements, and all that. So you can look more about on their website. Next thing we use is the Swagger CodeGen. That's an open source project. You can check their GitHub page here. Pretty cool stuff. It lets you generate REST clients for multiple languages. I just put a few here, the ones that work for us. So we can generate the PowerShell ones, the C#, but they have a very big list. So definitely check them out. That's not pure storage code. It's the Swagger guys. It's a very cool tool. Next thing, as mustache templates. That's actually used by the Swagger CodeGen. It's a template that uses, it's a logic class template. It works basically by expanding tags. So it has some limitation because you cannot do, for example, a if statement or a for loop inside of the template, but you can go through some hoops and do that with tags. And last, Zhenhao 2, which is a more powerful templating engine. That one actually lets you do like all this logic stuff, do the ifs and for loops, and gives you more flexibility on how you handle your templates. Okay, so our sample example, the pet store. Pet store is actually example from the Swagger team as well. You can go to the website, pet store Swagger.io. It has a similar page as you saw for the documentation of the Pure Storage REST client. It has all the operations you can do. It's basically a simple pet store. So you have your pet operations. You can add a pet, data pet. You can go to your store and you can place an order. So all the stuff. It's a much simpler REST call. It only has like, I don't know, like 15 commands or something like that. And you don't have to be handling authentication like you have with the flash array. So it's simpler for the demo. And on the top here, they also have the Open API specification. So all the information that you want to know. OK. Saw that. So let's go to the CodeGen part using Mustache. And so again, initial plan, we had the YAML file. We want to use this Swagger CodeGen, and we want to have a PowerShell module. Yeah. So actually, you can go to their GitHub page. It has all the instructions on how to do it. You can download the Swagger CodeGen. So all the cool stuff is there, well documented. Let me reduce this. So all you need to do, basically 2 things that you have to generate a REST client from zero. You have to download their Swagger CodeGen tool. I have previously downloaded here, but you can download from there. It has instructions on the GitHub page. And you need your Swagger YAML, so your Open API specification. So I'm just going to download this guy. Oops. So got the guy here. Again, similar style file that we already saw. And that's all you need. And you can just go and run their Swagger code gen. You pass the generate option. You're trying to generate the module. You pass your input file, your YAML, the language, in your case, PowerShell, and your output file, your output location. And if you run that, wrong case. If you run that, if it runs. Oh, I run the same thing again, sorry. There you go. Now, if you run that, it actually will generate all the PS1 files. So you create a folder here, pet store PowerShell. And if you go into the source here, let me just minimize this guy. And you can see all your PS1 files that do the operations. And you see your PS1 file here. So for your module. So cool, you have a module, right? Pretty simple. Actually, if you try to import this module, this will fail. Sorry. And you see that it's complaining because it cannot find some types here that it's looking for. And so on our PSM1 file, it's looking to create these objects for this type, but actually there's no definition of this type anywhere. The reason for that is that the code that is generated by the Swagger code gen for PowerShell, it actually depends on the C# library. But lucky for us, Swagger code gen can also generate a C# library. That's why they have this dependency. So basically, what you have to do is you run the Swagger code gen with the C# option. You're going to get the library from C#. You run with the PowerShell option. You're going to get your PowerShell files. And then you run a build file to basically combine the two of them and make your module. So let's give that a try. So generate the C#, same thing, just same options, but now on your language you're going to pass C#. Pretty straightforward. Go. And that will generate the C# folder here. Go into the source. You can actually see the C# code. And you can go to the client here. And you can see like here is actually where it creates the REST client and do actually the core operations for doing the REST calls. So cool stuff. Let me minimize this. And now what you have to do to combine the two of them is run this build file. It was actually generated when you try to generate the PowerShell module. So it's this guy here. And this guy does a lot of stuff, but one of the things that it does is it looks for the C# library. Where is it? Here? No. Here. There you go. I try to look for the DLLs for the C# library and everything. So let's run this guy. So. Take a little bit. There you go. It's running. This will actually build the C# library. We generate this bin folder here that has the DLL for C#. And it actually also generates this PSD1 file for your module. This will have the required assemblies. Okay, I need the C# library, and it has the exported modules, the export commandlets, sorry. So yeah, that's pretty much all you need, depending on your use case. This is a fully functional module. You can go to this location and import it. Sorry. And then you can actually go and get the commandlets for this guy. So those are the commandlets that were generated. So yeah, this might work for you, depending on your use case. If you just want to have like a simple REST client module, so you can do some things on your own code. This fully works. It does all the REST calls. It's amazing that you can do that just with a couple of commands. You just have to download their code gen. For our case, we want to make our customers' life as easy as possible. So we want them to have the best experience. If you look at the syntax here, it's doing like invoke dash whatever the class name was and the operation. If you have in your mind that you're actually using a REST client, that makes sense. You're invoking a REST call. But for our customers, we basically just provide them a tool to interact with FlashArray. So if they are a common PowerShell user, they will probably expect something like if you're doing a delete path, you might want to expect a remove pet store pet instead. Have the recognized verbs from PowerShell, something simpler. If you're creating a pet, you probably expect like a new pet store pet. So this syntax is not that user-friendly for a PowerShell user. Moreover, if you go, for example, let's take a look at one of the calls, for example, the place order. So basically placing an order for a pet. And if we do get help for this guy, and full, what you get is this. You basically get the name of your commandlet, syntax, one parameter that's called body of type order, but it doesn't really tell you how to get this object order. It doesn't have examples, so not the best experience, right? And so if you look a little bit into the module, you actually find out that to place order, you have to go and create this order object using the new order, and then you invoke your commandlet using that. And that would actually work and give you the, actually place your order, say here status approved and everything. So this works, but it's not as easy to use. And in our case, it was a little bit worse because some of our objects, there are complex objects that had complex objects inside of them. So it creates this cascading event that for the user to do one call, they had to do like create 5 objects and then do the call, and not the best experience. So we're like, okay, how can we do this better? So we went back, okay, let's see what the CodeGen people do, say that we can do. They were the one to create everything. So you look, they actually say, okay, you don't like our syntax? No problem, you can go and change your templates. So you can go on their repo, they actually have the templates from Mustache, and you can download them and edit them. So we did that. That's why I had this Mustache folder here. These are the templates that they use. If you go, for example, to API Mustache, it has the definition of how they're creating this commandlets. So it has here function, invoke, dash class name, dash operation ID. That's why everything looks like invoke pet store API something. So if you want to change that, we can do, for example, I don't want it to be the class name. I just want to be a simple PS for like pet store or PowerShell, whatever you choose. So you can do that. Oops. If you save this guy, and now you can just run. Let me just restart the session because if not, it's going to complain about my DLL. So now, if you want to regenerate your PowerShell scripts using that template, pretty simple, same thing, same command that we have been using, pass the language PowerShell. But now at the end, you're going to pass -t for the template, and you pass the path for the templates folder. So let's try to run this guy. That will generate the C#, the PowerShell files again. Now that you have the new PowerShell files, you have to also rebuild your module. So that works. So let's do the rebuild. That'll work. And then you can go and import and get the modules again. And that will give you your new commandlet. So now everything is -ps instead of the pet API or whatever. So there's a few things that you can do with the Mustache. But for example, to do the thing that I mentioned, instead of invoke something delete, do remove -something. You could do it, but it's a little hard. You have to go through a lot of loops with the tags to be able to do that. So we thought, okay, if we're going to have to be changing the template so much, maybe we might as well go to something more powerful that let us have more flexibility. And so with that, I'll give back to Zhenhao to talk about the Jinja 2.
Thanks, Daniele. So in this section, we are going to talk about how we use the Jinja 2 to render our templates and do the code generation. So wondering how many of you here have ever used the Jinja 2 before? That's a lot of people. Okay. But for those who are not familiar, no worries. I will walk you through how we use the Jinja 2 in the demo site. Okay, so let's take a look at the overall workflow of how we generate the C#, generate the whole PowerShell SDK. The first step, simple, using the YAML files, and Daniele has showed all of these steps to create the necessary C# library part. This is all native support by Swagger. And the second part is our own customized part. So basically, we use the YAML files, and we have our pure CodeGen. I will walk through you to this code part. What this part do is pre-process the YAML files and read them into a single data structure that will be used to rendering the Jinja2 templates. So once we have all of the data in the Jinja2 template, we will generate our PowerShell scripts. And we have our C# library and PowerShell scripts, these two core components ready, and we will wiring them up with some PSD1 files, and we will have our PowerShell module ready. So, demo. First, let's take a look at the C# DLL. And as you can see, this store API.cs is the C#, one of the class of the C# DLL. And we have one function Daniele has just demoed. And this is also the API we are going to use in the PowerShell, which is place order. And you can see this parameter type is not the basic type. It's the order class. And if we see here, goes a little bit deeper, there's a helper function of place order with HTTP info. And let's go to see the helper function to see what it does. So this helper function, it will create the, do the core REST communication. It will generate the headers, generate the body parameters, and serialize it. As you can serialize it. And it will make the HTTP request, and we can see the call API, and it will get the response from the server, read the status code, and demonstrate the final response to the user. All of these are regular REST communication we need to do, but all of this code will be generated by the Swagger. Will do it for you. Once we have the C# library ready, what we are going to do is in the PSD1 files. Daniele has demonstrated this part. We will import this DLL in the PSD1 files. So in our, when we generate the module, we will reuse this part, still importing the assemblies. And we will still create the C# API. And the different part is in our generated PowerShell scripts, we will use the placing pedestal as an order, and we can go to the downs to see how we do things for the user. So here, still using the C# DLL store API, the store API.cs class I have shown you, and call one of its API place order, and we will do this step for the user. As you can see, order object is created from the new order ID and pet ID, quantity, and all of the parameters. And user is going to pass these parameters in this single command line. So new pedestal order, we have all of the parameters, and user will pass in one single steps. And there's obvious, and user don't need to, oh, how do I create the new order and create all of the reference objects and then create. And that's basically our outcome of generated files. So how do we generate these files? Everything starts from YAML files. YAML files, we have all of the first part is like defining the metadata, and we have the descriptions, everything about your pets. And we have paths. Here I cherry pick only one endpoint /order/order /store/order. You will only see one URL and only the one function under it. So I choose the place order, which is the post function. So if there are other like deleting order, update order, you will see them at the same level. So make it simple. To place an order of a pet, it has the summary inside of it, and it has also had the operation ID. So place order, you will be familiar with this now, because this operation ID will be used later in the code generation. This is the name of the API function in the C# library we are going to use in the PowerShell. And also it has the parameters. As you can see, the tricky part is it used the $ref. So not all of the information is inside of these YAML files. we need to pre-process these YAML files after we read these files, because this is also one of the major step pure code generation does to dereference, resolve all of the reference in these files and do the stuff. And we can see the response, and all of this are defined in the YAML files and will be returned to the user. Now let's take a look at the other YAML files, and so it will be under the models directory. So when your the whole pet store get complicated, we will put everything in the model, and all of this model can be reused. So we don't have a very long YAML files that having all of the information. That's the benefit of using the reference. So order.yaml files, pretty simple. It has description, this is the order for the pet store, and it has all of the properties. It has ID, pet ID, quantity, and defines the type, loan type, and has the description of it. And all of this information will be used later when we generate the code as the parameter helper, and we will also listing the parameters in the PowerShell using the information of the YAML files. Now, let's go to how we generate the PowerShell using the Python. Okay, so main function, obviously, that's where we are going to start. And I'm going to use the breakpoints to stop at the core parts to help you walk through the whole procedure to understand how code works. Let's go to the debug modes and start. So arg parser, so for those who are familiar with Python, this is processing the arguments from the user. And here, basically, we read the YAML files, and we put the building directory, and all of the output will be put there. We have some other code generation, like generating some tests along with the codes. And once we have all of the arguments processed, we will go to our main helper, generate PowerShell code. Let's go. Okay, so you will see pure Swagger here. So pure Swagger here is the one I mentioned about the pure code generation. In this step, we are going to pre-process the YAML files and read them into a single data structure. And this data structure is the one we are going to use in the rendering the template. Now let's go into the pure Swagger to see how we pre-process the data. First step, read the YAML files. It's easy, simple, and we get the spec path, which is the pet store-original.yaml files. I just show you the first YAML files, has most of the information. And we read the YAML files into this underscore data variable. So obviously, if we just simply read the YAML files, the information will having some issues. So if we go to the paths, so remember the YAML files, we have the path, we have /store/order, and we goes into this, goes into the post function, and we goes into the parameters. We see it's the order parameters, and goes inside of it. We can see the schema is $ref /model/order.yaml. That means we cannot use this data when rendering the Jinja 2 because it does not have all of the information. So what we are going to do is continue. First helper is to resolve the reference. Basically, this function is going to do some recursive. So go down and, there's a $ref. I'm going to search this file and grab this information back to this data structure. And to see, there's another ref. I'm going to go into and grab information back to this data structure. And eventually, we will have one single Python directory, the Python map, to have all of the information of all of these models and all of these APIs and have the information in it. So let's take a look at the data now to see how it looks like. We have paths, and we have /order, /store/order. We go into the post function. We go into the parameter, go to the name of this order, which is schema. Oh, sorry, I didn't. Okay, let's go again. The slash other post parameters. First one. And cool, we have all of the information ready under this single underscore data structure. All of the parameters are inside of it. So as you can see, good, we have all of the information, but it looks like the data structure is a little bit complicated. We don't want to handle all of this, a lot of not necessary data in our Jinja 2, because parsing this data structure with another layer is kind of cumbersome. And we have our own another helper function to compute the parameter map. So this will have a simplified data structure having most of the necessary information. So once we are done, we go to parameter map data structure, which is under the self variable, and go to parameter map. I'm going to make this a little bit bigger. So you can /order, /store, /order, and we have the post function, and we have all of the parameters of this post function. Okay, simple, beauty. And we are have our parameter ready, and we are going to go to our next important process workflow, which is, oops, I think I skipped it. Store, let me start it again. Not this one is parse, read the YAML files, result the reference, compute the parameter maps, and stop here. So this step is going to identify the complex parameter. So what is complex parameter? It is the one, remember we knew order. We create an order object first, and then we pass these order objects to our C# API. And this is defined as complex parameter. The basic parameter is simple. It's string, integer, or a Boolean. We will use it directly. But with complex, we are going to identify it. And in the Jinja 2 files, we will check this marker. Oh, it's a complex. Okay, we'll do the initialization for the user. And once it's done, and user don't need to do this step. See, for complex, we will go to the data again. We have the paths. We have the /store, /order. We have the parameters. Good. And for now, there is no marker of the complex parameter. But after this step, we will see there we added a new field for this order object. We mark it as is complex, and this helper is fairly simple. You just go do some loop and check if it's a basic one. If it's a basic one, you don't mark it. If it's a complex one, you will mark it. It's simple, but do real important stuff. Now let's go back. Once we have all of data pre-processed, we will go back to the Python files. We will see some environment filters. And what is these filters? Filters are a definition in the Jinja 2. If you are familiar with PowerShell pipeline, I think it's very similar to it. It's kind of like you are going to define some function by yourself. So like we have another template helper file, get class name, and you can use these functions inside of the Jinja 2. So what it looks like is in Jinja 2, every variable will be covered by the curly braces. And you have a list, and you will have this the filters, and going to separate this list with comma. And once we have all of these helper functions defined, we will go to the next step. And this step is intuitive. We get a template from, this is the template we are going to use, PowerShell module.ps1.jinja2. And we are going to get the template object. And once we have the template object, we will go to a loop. So this model is the one we read from the pure swagger.parse. So this one is similar to the underscore data I have shown you. So if we take a look at this variable, we have the paths and we have all of the /store, /order and all of the information in it. So it will work through all of the paths under the models. So in our case, we just have only one path because I simplified the YAML files. We have the /store, /order, but in the real case, you will have a lot of paths and they will work through one by one. So for this single path, we are going to get the /store, /order, and we do some string manipulation and get some suffix, and we will use this suffix to define the PowerShell scripts, the name of the PowerShell scripts we are going to generate, and we also get some data to cherry pick some data inside of this paths, which use the model path, the /store, /order, to cherry pick the information of this single path. Okay, now with all of the information ready, we are going to render our PowerShell. We are going to render with the Jinja 2 templates. Go to the next. So we can have take a look at the data we have. One is the complicated one, having all of the information. The paths under, you can see there's step, and another step, having all of the information. We call it a model. We call it as a model, and this model will be later be a variable in the Jinja 2. And in the Jinja 2 template, you can get access to all of the information in this model. And also have the parameter map. And this is the one I mentioned to you. That is the simplified version of the model, having all of the information of the parameters. So, and we just do it. And yes, we writing the final PS results to the path store -order.ps1, and we will have the files ready. Let's take a look at how it looks like. So as I have shown you, this is the function name, parameters, and the core part of initialization, the reference, the complex type, and then call the C# API to present the output to the user. Okay, so Jinja 2 files. For better understanding, I will get you another column so that we can compare the Jinja 2 with the files we have with the .ps1 files. Sorry? Oh, okay. Good suggestion. Okay, so Jinja 2 files, how does it work? We have so every variable or like for loops or if blocks, it will be covered by this curly braces. And for anything that is not covered by the this curly braces, we are going to print it as it is. So you can see from the beginning of the file generated from PowerShell module.cs.jinja2, we will have the same thing in our PowerShell scripts, right? And here comes the interesting part. Macro, what is macro? It's the function, the Jinja 2 version of function. You have the function name and you put the parameters, you define it in the Jinja 2, and it will help you to render the views for you. So let's see, this macro, what it does is to generate the parameter description. It's the function name is called parameter comments, and it inputs is the parameter. So we have dot parameter, and this is the map, and we get access to the key name, and as you can see, dot parameter ID, dot parameter pad ID, and we will print it to the user. And the next macro is generate PowerShell parameter. So previous one is generate the comments, and this one is going to generate the PowerShell parameter. And it's still for a single block for every parameter. So it will check, set the variable. It's defining a variable in Jinja 2. Is this parameter mandatory or not? So we can see it's check. We have a check here, check if it's required. And we print the original name of this parameter. And we get the parameter attributes from the YAML files. And we get the parameter type. And we get the parameter name. And for this single block, we have 4 lines as well. We have some comments here. We put the parameter attributes. We have the parameter type. And we have the parameter name. And next, macro is the complex parameter initialization. So in the Jinja 2 file, we will check if it is a complex parameter. If it is a complex one, we are going to initialize for the user. So we have the new hyphen. So it will always be new hyphen some objects. So in this case, it will be new hyphen order. It will be creating the parameter mapped type. This is also the information we have because we need to map these parameters to type order because all of these parameters are from the order objects. And we will do a for loop through all of the parameters in this all of the parameters and do them one by one or generate the ID and getting ID and pet ID and getting pet ID and generate this line of creating the complex parameter. And the next one is the big one. So this is like a main function, and all of the macro I mentioned above, it's like a helper function, helper macro. And this main command line is going to do a generation from start to end. So before we look into this main function at end here, we check the entry point of this Jinja 2 files. So model, remember this is the very beginning data structure we send to this Jinja 2 files. So we get the paths, items, and we check if it's a get method, if it's a post method, it's a patch or not. We will invoke this Jinja 2 macro, the command line macro, with all of the informations, and it will start to rendering the contents in this main command line macro. So here, let's starting from how it looks like. So it has paths, getting the path as comments, and it defines the function, which also have the verb we defined, we send from the parameter, and goes to pet store, object name, and then we will start to rendering the function description. We have a synopsis from the summary. This is from the YAML files, and description also from the YAML files. And we will loop through all of the parameters and call the helper macro, the param comments. I have demo just now, and it will do a for loop and generate the comments for all of the parameter one by one. And once this part is done, we will go to our next part of listing function parameters. So we will have our parameter and we loop through all of the parameter and call the helper macro PowerShell parameter. And we'll go through the parameter one by one and generate it's the same. And interesting part is one of the feature I like. One of feature I like in the Jinja 2 files. It can check if it can check it's the last loop or not. If it's the last one, we will not print the comma. But if it's not, we will print the comma here. It's very easy to use. Otherwise, we will have a annoying comma here. Okay, and go to the process. Okay, go to the process, and we will have the reference type generated here. We see here, we check if it's complex type in the map mentioned just now. And if it's a complex type, we will call the macro to invoke the complex parameter initialization and do this line, generate this line. And our last step is to invoke C# APIs And we will see the operation ID I just mentioned in the YAML files, which is the direction you will use to find the C# API function name you will to use. And that's basically all we have in the Jina 2. And let's take a look at how the final results looks like. Clear the session. So I'm going to just loading the PowerShell scripts we have done. And let's see, a new pet store with no reference object and with brandly new name. And we will get the output from there. And let's see how helps looks like now. And we have all of the information from synopsis, placing order, description, and all of the parameters, and ID, pet ID, and description of this parameter, and all of the useful information in single one command. And thank you. That's the demo today.
Yeah, so just a quick recap. Basically, you go, your 4 steps are the generate the C# lib, you translate the YAML files, render your Jinja template, and then you can export your module. So that's pretty much it. Question?
Because I don't know if there were not more playing on it. I mean,
it depends on the size of the YAML file, but to generate this single one, we takes about 1 second. It's very fast because it's processing the Python, and it's just the read into the data structure. But once it gets bigger, it will take some time. But still not very long because it's just processing in memory, local in your computer.
That's all we have. I think we're a little bit over time, so I want to be respectful of people's time. But we're going to be outside on the booth, or you can have our contact info, so if you have questions, just reach out. And yeah, thank you for coming.